Now, I want to finish off the material on Cognito that I started with you the last day. And then I want to give an overview of the first assignment. Hopefully, you've had a chance just to read over it before now. And as I said then in the Slack message, Frank will be joining us to introduce his part of the module. So, got a lot to get through actually. So I'm going to go to these slides here again. And we started talking about this Cognito service the last day. So Cognito is the service that we use for managing our user accounts, essentially. I've positioned it as part of the state management side, which I guess is reasonable enough, even though it does provide quite a lot of functionality as well, specifically related to authentication. And with Cognito, the main resource, I guess, is what are called pools. There are two types of pools, user pools and identity pools. Identity pools are when you want to give users AWS credentials to directly access resources within your AWS account, like maybe give them access to an S3 bucket, a DynamoDB database, an EC2 instance possibly. That's identity pools. User pools then are when you want to provide your more kind of traditional authentication and authorization uh, support for applications, and that's the type of pool that we're interested in when we're talking about our web APIs. So how do we create a user pool in the CDK world? Pretty straightforward. This is how we did it the last day. And I did say to you, I'm going back over stuff now, I appreciate, but I did say that when you create a pool, you've got to create a client as well. Oops, sorry. I'm trying to pick up my pen. Um, you've got to create a client as well. And the client is what your lambdas use in order to tell the Cognitor service which particular pool you wanted to deal with when you're sending it commands. As well, when you create a pool, a user pool, sorry, you indicate, as well as with the client, you indicate the type of authentication flow that you're going to be using. So here we're saying we're using the user password authentication flow, and we're allowing users to self-enroll or self-register. Um, that's okay. And then I showed you, how the user pool looks. Sorry, now I'm jumping around the place. How the user pool looks in the management console. Oh yeah, there it is down here. That's all fine. Now, we then started to talk about your typical application architecture, I suppose you could say, when you're using Cognito with a web API. You don't have to follow this architecture, but it's kind of a convention, I guess, whereby you actually have a web API specifically concerned with dealing with authentication related requests, and you keep that separate from the web API that is the front end for your or the access point for your application's functionality. So we had all that the last day. Now, this is the one that we were interested in initially. So this is the one that's going to be receiving requests for user sign-up requests, user confirmation of sign-up, sign in, sign out. Each of those requests from your client is going to be proxied on to a particular Lambda, and the Lambda is going to be talking to Cognito to complete whatever action the user has requested. So that's fine. Then when we looked at the structure of this particular authentication API, it had this kind of structure here in terms of the different endpoints. Yeah. So there's a sign up endpoint, a confirmation of sign up endpoint. We need that confirmation of sign up because we chose, self-enrollment or self-registration, I suppose, as our authentication flow. There's a login endpoint, a sign out log endpoint. We also have an endpoint there called uh, current, which I don't actually use. And we then started to step through using this auth API, but we're particularly interested in also looking at the lambdas that are behind each of the endpoints on the auth API. And it turned out that they all had a similar uh, kind of programming flow to them. So what I've already done, and I did it with you the last day, is I've completed the first two stages of kind of authentication, if you like, which is user sign up and confirmation of sign up. So I've already done that. And if I go over to Cognito, this is kind of where I left off with you the last day. So if I go into user pools, I have my user pool here. And if I want to look at what users are in that pool, then I have my user A, and it looks like they have confirmed their registration and also their email has been verified. So we've got a user ready to log in essentially. Back to my slides. So for users sign up, because I chose a particular authentication flow when I created my pool, and for example, I said that email is going to be an alias for username. Then when you sign up, you need to provide these three pieces of metadata about the user: their username, their password, and their email address. And that's a post request. And when we send a post request with this payload to this particular endpoint of the authentication API, then the lambda that we are triggering is this lambda here, which we looked at the last day. Okay, so again, this is the lambda now. That is one of the lambdas here. So the lambda as within the event object that's passed to this lambda, and this is the lambda that is sitting behind a web API. So, what type of handler it is. It's an ordinary gateway proxy handler. And it gets its event object as always. And within the event object, we can extract the payload of the post request. Now, from a Cognito point of view, because this Lambda wants to talk to Cognito, the steps again are you create a Cognito service client, which is different now from the user pool client. This is just the Cognito service client. You create a command object. We talked the last day about all of the AWS services follow the same kind of programming flow from an SDK point of view. In this case, we create a sign-up command, initialize it accordingly, including specifying the ID of the user pool client and the information that the user provided as their login information. And then we send that command to the sorry, where do we here? We send that command to the Cognito service. And well, if it throws an exception, and it might throw an exception, that's caught here and it's sent back to us. Otherwise, we send back a 200 response back to the postman, in our case, was the client. That's fine. That's how sign up worked from beginning to end. Confirmation of sign up, same kind of idea. Post request to a particular endpoint. This is the payload in this case. We know that the code we receive from an email that the Cognito service sends to us. So it's the actual Cognito service takes care of sending the email. We don't have to write the Lambda code for sending the email. Although you can write Lambda code for sending emails, but we don't need to. We receive the code and we send a post request to this endpoint, send that, and the Lambda that was triggered is this Lambda, which has a similar kind of structure to the one that we've looked at. So I'm not going to talk over that. So that's where we left off. The next thing we want to do is allow the user to sign in. So to sign in, if I go to Postman at this stage, now I've already deployed my stack. So I've set up these two variables here for myself, the URL of the authentication API and the URL of the app API. And to sign in, I need to provide, as you might expect, username and password to this endpoint here. And let's just send it, I guess. Now what we get back is we get back a cookie in the response. Although I'm actually, sorry, we get back a JWT token in the response. Now I'm including the JWT token in the actual body of the response, but I'm also including it as a cookie. And so if I go to here in Postman, I can find what cookies were included in the response that was received from this request. And you can see here that there is a cookie whose cookies, as we know, are just key value pairs. So there was a cookie whose key is called token. And if we clicked on it, the value is this value here, which is a JWT token. Now, if I go back to my PowerPoint, so what happened is the user posted a login request to this API. That for proxied the request onto a particular Lambda. The Lambda sent a command, and we'll see it. I think it's in a what is it called? Sorry, it's a authentication initialization command. I think it's not obvious the name, but it's something like that. It sends that command to the Cognito service. The Cognito service obviously looks up its user pool to make sure that the username password combination are correct. And it then generates a JWT token, which is returned back to the Lambda. And my Lambda puts that token into a cookie and returns it back to the web API, which returns it back to the client. Also, as you saw there, the Lambda puts the JWT token into the actual response body, which wasn't really necessary, I suppose, but there you go. So that was the flow, right? And if we look at this Lambda, if I fast forward to that, again, it has the same, it has the exact same kind of programming flow or logic flow to all the other lambdas that are dealing with authentication. Create your Cognito client. In this case as well, because it's a post request, extract the payload from the post request, which is our username and password. Create the command object that we want to send to Cognito. And as I said, it's not a log, there isn't a login command. It's an initiate authentication command. But again, the, the the properties that we want to include in this command object is the ID of the user pool client, the authentication flow. Not, yeah, it seems kind of odd that we have to specify the authentication flow here because we did include that when we created the user pool, but it seems like you have to anyway. And the actual payload of the login request. And assuming then we send that to the authentication service here. The authentication, this particular request to the authentication service, from a programming point of view anyway, it returns an object. And all I'm doing here is I'm just using JavaScript destructuring to pick out a particular part of the object that was returned, which is called the authentication result part of the object. So that's a key within this overall object. And it's inside that object is where we get the JWT token, which I'm trying to access here. Yeah. And then I send my response, return my response back to ultimately the client. And you can see here I'm setting a cookie in the response. I'm giving a cookie. Again, as I said, a cookie is just a set of, it's a key value pair. I've chosen token as the key, but you can choose anything you want to. And the value is the actual JWT token kind of hash value. I'm also including the token. I'm also including the JWT token here in the body of the response, and you saw that. So I've now kind of completed most anyway. Sign out is pretty straightforward, but completed all the stages of authentication. What's next? Oh yeah, that's okay. Oh yeah, sorry, just go back to Postman. So here's the cookie. Sorry, here's the JWT token. So I want to grab that and I want to put it into my Postman collection. Sorry, bear with me now. There's stuff getting in my way from Zoom. Just going to cancel out of that maybe. Go into here. So I've just got a Postman variable called that. And what I want to paste in there is the full cookie. Again, the cookie is the ID equals, sorry, the key equals and the actual value. So I'll save that. All I'm showing you here actually is, so a JWT token is encoded, obviously. But what information is actually contained within a JWT token? So what I'm showing you here is just a screenshot from a website whereby you can paste in on the left-hand side a JWT token. And there's a button that you can click that says decode this token for me. And what it shows you on the right is the actual decoded version of the token. And the reason I'm showing you that is because if you see here, there's some useful information contained within the JWT token when you decode it. Specifically, it includes the username of the user that logged in and also their email address. So they're two useful pieces of information potentially for your code if you want to find out on whose behalf was this JWT token generated. Right. So and you can do this programmatically. You can do this decoding programmatically. This is just a nice, convenient website, but there's a library that you can use to carry out this decoding for you. And the decoder will return an object. And if you index into that object, you'll get these two pieces of information, as well as all the other bits of information. Right. So at this stage now, our user, our client, I guess we should really say, has a JWT token, which they can now use to access the functionality that lies behind this web API here. If that piece of functionality requires authentication, maybe some parts of it are public, so you don't have to pass the JWT token. For those parts of it that are protected, the flow is the user sends the request to the particular endpoint of the functionality that they want to access. The uh, the REST API will first of all consult with another Lambda called the authorizer, and it will pass that Lambda essentially the full event object that it would ultimately pass on to the Lambda over here. Okay, it passes it this Lambda that event object. So that event will include the JWT token, which I have decided to pass as a cookie in the request rather than as a payload. So now this Lambda, what it can do is it can just simply get at the cookie that contains the JWT token. It will talk to Cognito and essentially ask it to verify that it's a valid token, that it's a token that it generated, if you like. If it comes back and says it is, then this Lambda, it needs to essentially tell the gateway that you can proxy the request on to the backend Lambda over here. And the way we do that is using AWS's own kind of mechanisms, which is to dynamically create an IAM policy, which will essentially tell the gateway that you can send the request on to the backend. The policy will be an allow policy if the JWT token was a valid one. The policy would be a deny policy if the token was invalid. So it's kind of nice that we're actually using AWS's own kind of security service to communicate that fact between the authorizer and the gateway. From a CDK point of view, how do we kind of create all this stuff here? All of this? Well, we know how to create a gateway. We know how to create lambdas. This is just another lambda, but it's because it has a specific role. We need to tell the gateway that this is the lambda that you should use as an authorizer. So I'm showing you excerpts from the CDK stack here. Okay, I'm creating a REST API, nothing new there. Creating two lambdas. I've just arbitrarily decided that there are, sorry, now we're jumping around. There are two lambdas over here. One of them is a public one of them is a protected one. So that's these two lambdas here. I've collapsed them because we don't need to know the detail of them. The third lambda is the lambda that will play the role of my authorizer. But in just in terms of creating that lambda, it's just another lambda. So there's nothing, it's still a Node.js function. Um, uh, oh, sorry, beg your pardon. These are the two endpoints of my REST API, the protected endpoint and the public endpoint. These are my lambdas here. So, sorry about that. These are the two lambdas that are kind of representing these guys over here. The third lambda is the lambda that plays the authorizer. But here's where we essentially wrap this lambda, wrap it as an instance of a request authorizer. So then this is just another L2 construct, CDK L2 construct. So we're wrapping our lambda, and here we're kind of referring to the lambda. This is a reference to this lambda here. We're saying that here we're indicating where within the request that came from my client is the JWT token contained. And I'm saying, look, it's going to be contained within the cookie request header. That's the purpose of this entry here. And all I'm saying here is I'm telling API gateway not to do any caching of the tokens, which kind of makes sense. So now we have an authorizer. The next thing we've got to do is add on our endpoints. So there's a get endpoint. And because we're saying this here, we're saying that this get endpoint requires user authentication. In other words, the request needs to include a JWT token, and this authorizer needs to be consulted. So this here and these two entries really kind of go hand in hand. This is just a reference to the authorizer. This is stating what the type of authorization is, and we're just using custom authorization. There is an inbuilt authorizer as well, but we're kind of writing our own, if you like, which is in this lambda up here. There's a second get endpoint, but this is an ordinary get endpoint, so it doesn't have any of this stuff here at all. So it looks like that this second endpoint is a public endpoint. So that's the CDK code. And so if I just simply try and access, if I try and access this endpoint here from Postman, so it's going to be it's going to be, sorry, no. It's going to be a GET request to the /protected endpoint of the app API, not the auth API, of the app API. And we need to include the JWT token as a cookie. So when I go to the headers part of Postman, Postman will already have set up some headers. So these headers here were created by Postman itself, and you do need to actually leave those as they are, because I found if I disable these headers, then things don't work for me. But I have to add a header. I have to add this cookie header, and the cookie header, its value is a set of cookies. Cookies, as you know, I've already said, a cookie is a key value pair, but you may want to send more than one cookie in the cookie header. And you just separate the cookies with a colon. So strictly speaking, this is could be a string, a colon separated string, where each entry is a key value pair. So if you can imagine, you have key equals value, colon, key equals value, colon, key equals value, and so on. And that entire value is interpreted as a big long string. Now, in our case, there is only one cookie that we want to send, and the cookie that we want to send is set up in a nice convenient variable for us, which is this variable here. But you can see that the value for this variable is key equals value. So it follows the cookie structure, if you like. So if I now send this request, I don't get what I expected. Did I not save something? Maybe I didn't save something here as usual. Let's try it again. And where did I go wrong? I don't want to spend too much time on it now if it's not going to behave. I did paste in the token, didn't I? If I go back to here. Save that. Okay. So where did that come from? Well, if I go to the actual lambda that I want to access, which is this lambda here, and it returns this, and that's what we got in Postman. Yeah, that's what we got in Postman. If I try the same request without the cookie, well, you've already seen it actually, but then you get an unauthorized response. Actually, that's not the exact response that I got earlier on. So earlier on, what I was doing was, well, by earlier on as in 20 seconds ago, I was sending it a cookie that I think essentially had expired, possibly. I didn't read the actual message, but slightly different one from unauthorized. It did receive a cookie, but it was a either an expired cookie or There were some issues with it anyway, which made sense. I'll pause for a second just in case there are any questions so far. I know I'm jumping around in terms of the slides anyway, but no. Okay. Uh, there's a second endpoint in my app API, which is this one. Not too interesting, really. This one does not require a authentication. If I go back to my slides, so I have this path within my API, and it has a get method associated with it, but there's no authentication configuration, so it's completely public, and therefore I can access that without any cookie. And even if I send a cookie, it's probably going to be ignored. I send it without a cookie first. So that came from the second app Lambda, which is this guy. Yeah, that matches up. Okay, now all that's left is, if I go to here, this authorizer, rather than stepping through the actual code itself, what I've shown on the slides is sort of an explanation of the steps that it goes through. The very first thing it does is, I'm saying, it parses the HTTP request that came from the client. It parses, and in particular, it picks out the cookie header. And in general, the cookie header, as I've said, the cookie header is just a big long string, but from a structural point of view, it's a colon separated string. Uh, yeah, colon separated string, where each part is a key value pair. Now, just for convenience, what I do in the authorizer lambda is I take that long string and I just essentially just chop it up into its key value pairs and store those in a map data structure just for convenience. Having done that, I then check to see, is there in this map, is there a key called token, which there should be. Otherwise, it means that the request doesn't contain a JWT token. Why am I looking for the key token? Because why am I looking for that token? Uh, oh, sorry, no, no, sorry. I've just arbitrarily used the used token as the key of my cookie, whose value is going to be the JWT token. Okay, so that's kind of hard coded, really. And if I do find a key within the map called token, then the corresponding value is the JWT token. Of course, if I don't find it, then I create an IAM policy dynamically, which denies access to the backend, and that's the policy that I pass back to the web API. If it gets to here, we now have a JWT token, but we still have to get the Cognito service to validate it. So I ask it to verify the token. I get it, and I get Cognito to do that. If the verification is successful, again, I dynamically generate my IAM policy that says you can allow this request to go through to the backend, otherwise deny it access to the backend. The code itself, you can step through the code if you want to. It starts here. I don't think you really need to go through it, right? But you can scan over that yourselves. And it's using this utilities uh, file to, do some of the low level stuff. Like this is the function. This is a function that parses the long cookie string and breaks it up into a map. This is a function that talks to, doesn't actually talk to the Cognito service. It talks to an endpoint that the Cognito service provides for the purpose of doing the validation. It's actually that there is where actually, as I said, uh, a Cognito endpoint where we send requests to and ask it to verify a JWT token for us. And this is a convenience function that creates an IAM policy for me. You can look through that code, but don't really have to. Now, as usual, I am not as far as I want to be, but I've finished those slides anyway. The next thing I want to do is uh, talk about the assignment. What you've got to do is develop a web API for managing movie reviews. We've just stuck with that kind of movies context, and also create the CDK stack for the creation of the various infrastructure for that web API. Delivery date, percentage, that's all fine. What you're actually going to be submitting is a simple text file to Moodle. That text file will just have two entries in it, two lines in it. One will be the URL of the GitHub repo that you use to host your solutions code. And the second one is the URL of a short YouTube video that you will make demonstrating your API that it's functioning. I'll talk to you about that some other time. Put those two URLs into a text file and upload it to this link on Moodle. It's very important that the GitHub repo that you create, you set its visibility to private. Otherwise, potentially people may plagiarize your work. So set it to private. And when the deadline has completed for this assignment, I will send a reminder message to you on Slack to change it to public so that I can then access it. It's very important that you maintain a Git log right throughout your work on this assignment. So every time you essentially sit down to do some work on it, you should commit at the end of that session, even if you're in the middle of developing some particular feature and it's not completed, you should still do a commit. So I would expect to see a significant commit history over the 2 or 3 weeks that you have to work on this. There'll also be you'll have to write up a short README for the repo, but that'll probably take you about 1 hour, I'd say. So that's not significant. And I will give you a template for that README. In terms of the API itself, um, I'm specifying the endpoints that you need to develop. So there needs to be a get endpoint with this for this particular path. And we're specifying a movie ID and a review ID. Sorry, just a movie ID. Yeah, we're specifying just a movie ID. So that should return all of the reviews for that particular movie. In addition, you can optionally add in a query string that looks like this, where this query string specifies a review ID. And when you take that review ID and combine it with the movie ID, then you have a specific review. So that should just return one review or nothing if the review ID is invalid. Post will allow me to add a review. Put will allow me to update a review. The third, or the last, sorry, endpoint will allow a user to request a translation of the text of a review. So in this case, we specify the review ID and the movie ID. That combination will pick out or should pick out a specific review within your DynamoDB database. And also as a query string, we are specifying the language that we want to have the review translated to. There's an AWS service called the Translate service that will do this translation for you. Uh, so that's just the high level functionality, I suppose, that the app, the Remove Movie Reviews app needs to support. And it doesn't need to have any other endpoints other than these. Uh, from an authentication point of view, what you should do is take the Cognito code that I have provided you with and essentially stitch that into your movie review app in the same way that you would have done in the labs. So I'm allowing you to take all of that code that I provided in the Cognito lab and reuse it essentially. Okay, that's that. So there's nothing really other than cutting and pasting that you need to do to satisfy that there. From an authentication point of view, I do have some constraints. I'm saying that post and put requests can only be allowed if the user has already authenticated. In other words, they need to have a valid JWT token included with them. That should be straightforward enough because once you've completed the Cognito lab, you'll know how to do that. I have an additional authorization requirement here, though, which is that only the person that wrote a review should be allowed to update that review. So you need to think about how might I achieve that. In this section here, I'm talking about this Amazon Translate service, and I have a link to a video. And if you watch that video, the presenter explains exactly how you can use or invoke the Amazon Translate service from a Lambda. So you watch the video, and I think he probably provides access to a GitHub repo as well. So you can cut and paste some code from that repo if he does provide it, I can't remember, and reuse it and adapt it, I guess, a little bit for your own use case. I'm also saying here that it would make sense that if you get repeat requests for the translation of a particular review text and to have it translated into a specific language, then rather than requesting that translation or sending that request onto the Amazon Translate service every single time, which, when you start going into the hundreds of thousands, that's costing a lot of money, then maybe you should persist translations into your DynamoDB database. And that means when a user now requests a translation, you first of all check to see, is it already in my database? If it is, serve it from there. Otherwise, go talk to the Amazon Translate service, uh, get it to do the translation, then persist it into your DynamoDB database and return it back to the user. From the DynamoDB table, I'm telling you exactly, look, these are the properties of the attributes that you should have for your DynamoDB table. I'm telling you what the partition key is. I'm not telling you whether you need a sort key or not. Maybe you do, maybe you don't. You have to decide that. The review ID property, you just need to generate a number, kind of a random number using maybe the math library to generate a review ID. So that your Lambda will just generate that when a user posts a new request. It will generate it and store it in the review ID attribute of the table item. The reviewer ID will be essentially the email address of the reviewer. Um, that would actually be contained within the JWT token if you followed what I was saying earlier on. So the user doesn't really have to include their email address when they post a review. You can get that from the JWT token. The review date is just going to be a string, so you can just include a date string in the post request. But there isn't going to be any real validation. You could if you wanted to, but it would have to be based on regular expressions, I guess. And then the final part is the actual text of the review. So that's going to be a long string, presumably. Note you can assume, what can you assume? You can assume a review item, movie ID, and review ID combination are unique. So that tells you something about the primary key. Number two, that reviews are published in English by default. So let's assume everybody posts their review text in English. So that will help you in kind of the translation, because when you talk to the Amazon Translate service, you've got to tell it what is the language used in the text that you're sending me, and what uh, language do you want me to translate it to. So uh, now I'm running out of time. Can I just check actually, has Frank joined us? No. Okay. Uh,
I'm here.
oh, okay, Frank. Yeah, I'm actually
I'll
going
take
to.
your time, Dermot. You take your time, no problem at all.
Yeah, okay, sorry. Uh, what I just wanted to do actually was, if I go back to our Cognito example, and if I go into the protected endpoint, which is this one here, what I'm actually doing here is, and I've done this just to help you really. So this is a protected endpoint, but this endpoint has access to the JWT token that was included in the request. Yeah. Um, and I'm doing the same thing as I was doing in the authorizer function, which is I'm first of all extracting the long cookie string and putting it into a map structure. I'm then looking to see, well, was there a cookie? If there wasn't any cookie in the request, then can't go anywhere really. Send me back a 500. Uh, I'm also asking Cognito to validate the cookie. So admittedly, now we are doing the same thing that the authorizer did, but there's a reason for this. Uh, so I'm asking Cognito to verify the token, and what I get back from that function is a, what do I get back? Yeah, what I get back essentially is what you see on the right here, which means I can now go in and get the username and the email address of the user that sent that request. And all I'm doing is I'm console logging the actual token here. right? So if I go to CloudWatch, go to CloudWatch, go to the log groups. I want to pick out the log group for this Lambda. Where is it? There it is there. Get the log stream. And from looking at it earlier on, I think this is the part of the stream that relates to the console logging of the JWT token. So if I expand that, and you can see here, it was user A that sent the request. That person's email is this. Okay. So within the Lambda itself, this is the backend Lambda now, not the authorizer, although the authorizer could do the same thing. The backend Lambda can access the JWT token, and in particular, they can identify who has actually sent this request. Okay, that might be useful to you for the assignment. Back to the assignment. The grading spectrum, if you're just aiming for a 40 to 50 grade, then all you need to do is just have, I'm saying have basic CRUD, even though delete wasn't part of the spec, so you don't really need the delete. So for 40 to 50, you simply need to have this get working without any query string, the post working, the put working, and you don't need to have this one. For 50 to 65, I'm saying you need to have support for the full get reviews, including the query string and the translation endpoint working as well. Secondly, you need to stitch in the Cognito stuff for the authentication and authorization. So it's expected that you will have users sign up confirmation, sign in, even though I'm giving you all that code, okay? But you need to just um, stitch it into your solution. And you also need to ensure that posts and puts are protected endpoints. If you're moving up higher again, you need to have all of the above plus what I'm talking about here. I'll come back to this in a second. From a performance point of view, I'm saying you should have persistence of the translations into your DynamoDB table. You should have what I'm calling restricted review updates. That's this idea that only the originator of a review can actually update it. No, everybody is not allowed to do a put. Only the person that posted the review in the first place can do a put. This thing here, custom constructs. You saw in the Cognito example where we essentially took a section of our stack code and put it into a class of its own. And that class's type was a construct class. If I go back to here, you might remember when I looked at the lib folder, I have, these two here. They're not stack files, they are instances of constructs. Okay, so they are our own custom L2 constructs. So what I'd like you to do is just take a chunk of code out of your stack file and put it into a custom construct. You already have the two constructs from the Cognito lab, but you need to create a third construct. And you can almost take an arbitrary chunk of code out of the stack file. Ideally, though, try and pick something that is logically a unit within itself. But see how you get on with that anyway. Of course, you might decide, I'm not going to bother with that. I will do that, and I'll do this, and you still get, most of the marks in this grade band. You might leave that out entirely. The last thing is, now I am really gone over time, so I probably will need to come back to you at some stage. Maybe, Frank, would it be okay if I went down for another 10 minutes?
That's fine with me, Dermot. You can take as long as you want. Do you want to take the rest of the class? It's fine. I
Um,
can, I can make up the difference anyway, maybe with I have videos and stuff, so that's okay. But you can take what you need.
you know, would it be better for the students rather than me trying to rush through it now if I just took the rest of the class?
Yeah, that's fine. No bother at all.
Yeah, I'm really sorry about that now.
Panic. No, no, not at all. Not at all. Sure, look, it'd be better maybe if I just start fresh next week anyway with a full
Yeah,
introduction to React. So that's okay.
let's do that. Okay.
No panic. Perfect.
Thanks.
Okay.
Thanks. Bye-bye. Right. Just in relation to, if I go back, so in that case, I'm talking here about persisting the translations into your DynamoDB. Now, like up here, I'm saying, look, your DynamoDB table structure needs to have this in it. But DynamoDB is a schemaless database, which means you can have an item, a record, that has these properties in it. Uh, the next item in the same table can have these properties and some other properties. The next item in the table can have these properties and some other properties which are not the same as the properties of the second one, and so on and so forth. That's what schemaless means. The only requirement is every item has to have the primary key properties. Now, you have to decide, is my primary key going to be a simple or composite? But apart from that, the items can have any attributes they want to in them. Now, clearly, every item should really, in your table anyway, every item should have all of the other attributes, but some items might have more attributes. Uh, that's point number one. Point number two, an attribute can be a scalar type, which is a string or a number or a Boolean. But I also told you that attributes can be documents, where a document might be an array of things, an array of objects, an array of scalars, um, or it can be sets or lists, right? So you just need to remember that. Okay, so that's just some hints in relation to translation persistence. The hint in relation to restricting updates to the originator of the review in the first place. Um, you can, that's kind of related to what I was showing you there about accessing the JWT token from within your backend Lambda. Which brings me on to the last grading category, which I've just called outstanding. So it's in the 80 plus category. And what I want you to look at there is something called API request validators. Now, this is a topic that we have not looked at all. And so you're going to have to do a little bit of reading up on it. Everything else, Okay, admittedly, we haven't looked at the Amazon Translate service. We haven't looked at that, but I think once you watch this video, I don't know what it is, about a 30-minute video, uh, you should be pretty okay with using it for this assignment. I don't see that as being overly challenging. Now, so let's talk a little bit about this part here. And what I've done is, just to give you an overview, the first thing I'm going to do is pause actually. Are there any questions from ye so far?
Yeah, Dermot, just one question from me. Just in terms of the DynamoDB setup, when I was looking at this review this morning, sorry, this assignment this morning, what occurred to me is that maybe I'd look to layer the movie reviews table in on top of the movies table that we did in the labs, as opposed to, so have the reviews table instead of the casts table, for example. Any value in doing that for this assignment, or would you still recommend not just keep it to one table and build the stack and the functionality around that?
Um, as a mid interim solution, you can do that. You can just take out the movie cast and put in movie reviews and leave the movies table there. But ultimately, when you submit to me, I should only see one table.
Okay,
Anyway, and it's common kind of not so much mistake, but because most people come from a relational database background, they think, well, if I'm going to have movie reviews table and a movie review contains movie ID as a property within it, then I must have a movies table so that there can be referential integrity between the reviews table and the movies table.
that's
But of
exactly where I
course,
was coming from. Yeah,
yeah, but of course, there is no such thing as referential integrity when you're talking about any NoSQL database, including DynamoDB.
okay,
So you can have just one table ultimately, which call it whatever you want, movie reviews. One of the properties is going to be movie ID, but that's not going to be kind of pointing at any other table. Yeah,
understood. Yeah, no, thanks for that, Dermot.
great. Yeah. Anything else from anybody else? Okay, let's yeah, sorry, I'm there. If you can do this later on yourselves now, but if we go back to here and to this set of slides here, to really the slides I was looking at earlier on, let's bring up those slides. Now, the very beginning of these slides is where I started talking about API gateway, yeah. And what I've done is at the end of that section, if I keep going, yeah, this slide here and this one are three slides that I just stitched in there maybe at the end of last week. So they weren't in the original set, and I brought them in for the purpose of just giving you an overview of this uh, area of request validators. Now you'll remember if you've worked your way through the lab, if you worked your way through the REST API lab, that in the lambdas, we were carrying out validation on the requests. We were validating the query string, validating the body of a post request, validating the path parameters. All of that was being done in the Lambda. But you can actually get API Gateway to do some of that validation for you. And clearly, that might be a better approach because then if it finds any violations, then it doesn't bother sending the request on to the Lambda. It will generate an error response for that it will send back to the client. So the extra hop from gateway to Lambda is avoided, and again, that reduces cost overall. Now, the amount of validation that you can achieve, I'm saying here, I mean, this text here I just took almost straight out of the AWS documentation. It's somewhat basic in terms of the validation that it can do, but that might be enough to just stop certain types of requests reaching your backend lambdas when clearly there isn't enough data for the lambda to execute successfully. So that's the idea of these request validators. So just to read it, we can configure API gateway to perform basic validation of an API request before proceeding with the integrated request. In other words, before sending it on to the backend, which is a Lambda in our case. When the validation fails, the API gateway immediately fails the request and returns a 400 error. That's good. To the caller, and the validation result. Oh yeah, so it returns a 400 status code response to the client, and it also writes a message to CloudWatch if you want to get some more detail on the actual error that it found. This reduces, as I said, that's okay. You can, what can you validate using this approach? You can validate path parameters. You know, for example, if this is the endpoint, this is a path parameter. Now, all you can do from a validation point of view is check to see, was there a parameter included in the request? You can't do anything like, you know, is it a valid movie ID? Clearly, I suppose, you know, it can't do that level of validation. But if there was no movie ID at all, or if there was no path parameter included in the request, then there isn't much point in sending that onto the Lambda. If there is something there, send it on to the Lambda, and it will then check to see if it's a valid movie ID vis-a-vis the DynamoDB table. So basic path parameter validation can be done. It can do validation of query string parameters, but only those query string parameters that are mandatory. And sometimes, you know, some of the query string parameters, some of them are optional, some of them are mandatory, and that depends on the, you know, the specification that you are trying to satisfy in your implementation. But for query string parameters that are mandatory, then you can get API Gateway to validate those. And that would apply in our assignment because in the translation endpoint, we have a query string where we specify the language that we want the translation to be done in. And clearly, if that's not included, then, you know, there isn't much point in sending that request on to the particular Lambda that implements that functionality. Thirdly, you can get API Gateway to validate the structure of the body or payload of a post or put request. Mainly post requests we tend to use it with though. And what it will do is it will check the structure of the payload. And it's quite good actually here because it'll check to make sure if there's a particular property within the payload that should be, let's say, a numeric property, it will catch that. If it's a Boolean property and it doesn't have a true or false value, it has some other value, it will fail that. So that's quite good actually, that part of the request validator. So they're the types of validations that it can carry out. And we express all of this in our CDK code, in the stack code, and which is really, as we know, translates into CloudFormation stuff. But so there are kind of low-level resources, API gateway resources that we need to create in our CDK stack file to achieve all of this. And there are really actually only two types of resources. There's a validation resource, a validator resource, sorry, and there's a what's called a model resource. So we would presumably the CDK framework has L2 constructs that allows us to create instances of these two types of resources. For a validator construct, from a configuration point of view, the kind of things you need to specify are these things here. You need to tell it which particular REST API are you associating this validator with. So the REST API, we know how to create a REST API. That's kind of the top level resource, yeah. Well, when you create a validator, you need to link it to a REST API. You need to give the validator just an arbitrary name, kind of an identifier. And thirdly, you need to tell it what type of validator is it. Is it a parameter validator, i.e. path or query string validator? It kind of doesn't really make a big distinction between those two. So is it a parameter validator or is it a body validator? It could be both, actually. You can have validators that do both. So that's the validator. So as I said, there's an L2 construct that will allow us to specify those resources. The model resource is linked to validating of a body or a payload. And what the model is essentially it's a JSON schema which API Gateway uses to check the structure of a payload. Now, the JSON schema is very similar to the JSON schema. In fact, it's almost identical to the JSON schemas that we were using with the JV, what do we call it? The AJV library. So you've seen these kind of schemas before. There is a slight change you have to make to the schema though for it to work with, sorry, did I jump a screen? Yeah, so it's the same idea as the schemas that we were using with AJV. There is a tiny alteration that you have to make to those schemas though. You might remember from the labs, we actually had a utility that generated this JSON schemas for us from the TypeScript types that we had defined for our application. You can still use that utility to generate those schemas, but you then have to take them and make slight changes to them. I'll talk about that maybe in a second. So, but from an API gateway validating perspective, we use the term a model. That's the L2 construct that it talks about. This is my kind of visual representation of how all of this hangs together. So I've got a REST API here, and I've decided to use circles to represent endpoints. A diamond represents a validator, and a box represents a model. Okay, I've just chosen those symbols, yeah. So an API gateway, has many endpoints. We know how to create endpoints. Some endpoints may not have any validation. So that looks like this might be an endpoint that doesn't require any or performs any validation of requests. This endpoint here, it has a pointer to a validator. And because there's no model involved, it looks like this validator is either a path parameter validator or a query string parameter validator. This endpoint also has a validator and it has a reference to a model. So this validator is either just a model validator or a body validator, or it could be a body validator and a path stroke query string validator. You can't really tell from the way I'm using these symbols. The other thing just to notice is, the direction of the arrows. What I wanted to get across there is you can create a model construct, and that model construct needs to refer to a REST API. So you could use the same model for different APIs that you might have within an overall application. Doesn't apply in your case. The API, but anyway, you create the model kind of independently of the REST API. But when you create the model, you do have to in your configuration of it, it says you've got to point it at which particular REST API or APIs do you want that model to be used with. Similarly, when you create a validator, you can create validators independently, but when you create an endpoint, you do then have to specify which validator uh, is it using. I think it can only have one validator, but you could use the same validator for more than one endpoint if it came to it. Not sure if that applies in your case. It probably doesn't actually. But again, what I'm trying to get across is also, sorry, if there's a model being used by a validator, the endpoint needs to refer to the model. You might have expected the validator to refer to the model, but it looks like when I looked at tried to hack up some code to get all of this working, the endpoint pointed at the model that it wanted to leverage, and it also pointed at the validator that it wanted to use. So kind of that's anyway that's kind of my way of visually representing how all of these are individual cloud formation resources, cloud formation stroke CDK resources, and also I wanted to get across the direction of referencing that applies. Now, I have played around with this myself. Fortunately, I can't show you the code, but I can show you the code working. If you just give me a second. Okay. CDK deploy that. We let that work away. I was talking there about the models, and so what we're looking at here actually is the REST API lab that you worked on in the labs. So like the lambdas are add a movie. Well, we didn't have delete, get movies, get movie by ID, and so on. Yeah, so we know about those. And as well, we had here was our movies, and we had some types. Yeah, we had a a movie type, and we had a movie cast type as well and some other ones, but the only one we're interested in actually is the movie type. Um, and we know that for that type, we can generate a JSON schema, and we did that. And the schemas we put into this file here. And this is what a schemas looked like. Yeah. I don't know if you took the time to look at this JSON file, but let's see. Oh yeah, so here's the movie schema, and further on down we have the movie cast schema. Now, in order to we cannot use these schemas directly with um, with the CDK model construct. We've got to make a slight change to them, and so the change I can show you. So if you see this schema here, what you need to do is essentially copy that schema. You can get the utility to generate the schema. In your case, it would be a movie review schema. But having generated, you then need to just copy the schema, put it into a new file. In my case, I put it into this file. It doesn't really matter where you put it. And and you need to import the CDK API gateway library. You can see here I am, oh yeah, you need to import the library, paste in your schema. Trying to find the movie schema. Where did I put it? Oh, here it is here. Here's the movie schema. Now I pasted it in down here, but then I had to make changes to it. One change, well, I had to change one part of it. Anywhere I had a type property in my schema, so maybe if I try and leave both files open now, we can get a better sense of what I'm trying to get across here. Here's the schema that was generated for me. And for types, we have things like Boolean and string and so on. Yeah, number. I can't use those as types in the JSON schema that I want to use with my model. Instead, what I've got to do is to change them like I'm doing here. I'm using the API gateway that I've imported at the top, the reference at the top, and I'm pulling out essentially definitions within that library. So API gateway.json schema.string instead of just the string called the string with the value string. Like if I delete this and go just dot, here are the different types that are valid for our model schema. And once I made that change, then when I used it creating my model L2 construct, it worked fine. It didn't work fine if I just change this back to change it back to, don't know if this is making any sense to you now, but I just change it back to string. Yeah, that didn't work for me. I was essentially getting a compilation error for my model construct when I tried to do the CDK deploy. Well, in fact, even before I did the CDK deploy, it complained that, in fact, am I getting, you can see here, actually, I'm getting the error message, I think. Let me just undo that.
It's line number 15.
Pardon?
Uh,
Well,
it's line number 15. You left something there,
I,
a
pro
dot.
I probably did, yeah. I'll just undo it this way. Um,
Yeah, yeah.
yeah, okay. Like if I go back to here now, I say, look, I'll just leave it as it was when I got it generated for me. It's not complaining there, but it will complain. I think it will complain when it will complain when I link this to a model, and I can't show you that code because then I'm showing you some code that you need to discover for yourselves. But take it from me, you do need to make that slight change. Okay, where are we? I've deployed my stack, and in my stack, I do have these validators built into it. And so just to show you them working, I need to get the URL of the stack. Oh yeah, don't worry about this one. This is for something else. So this is the one I want. So if I want to add a movie, now in my implementation of the add movie endpoint in my stack, I have a model and I've got a body validator. Uh, the structure that we have here is a valid structure for a movie. But let's suppose I just take out one, and my model schema is looking for all of these properties. If I just take out one of them, and I post this, so this message here is being generated by API gateway. It's been generated by the validator, really. And it's saying that the request body is invalid. Okay, you don't. Maybe if we went into CloudWatch logs, we might get more detail on that. You can look at that yourselves later on. But if I put the property back in, and then maybe if I just flick over to DynamoDB. DynamoDB, sorry. So the movie ID that I want to post is 34567. Looks like it got through, and I guess we should see it there. There it is there. Yeah, so that seemed to work. Now, what I can show you is the benefit. Well, there are a couple of benefits for introducing these request validators. One is, it doesn't reach the lambda if the body is invalid, but also if we look at the actual lambda that handles the post request, which is this one here. And what I've done is I've commented out the code that we no longer need, because in the labs, we were doing the validation using the AJV library uh, in the actual Lambda itself. But now I can strip away all of that code from my Lambda. So all of the commented lines here are lines of code that I can now remove from this Lambda. Here's where we were doing other validation, checking was there a body at all in the request, and the request validator, the API gateway validator, would have complained if there wasn't a body. So we can get rid of all of that. We can get rid of all of this stuff. So our Lambda has also slimmed down a little bit as a result, as you might expect. That's a body validator. In terms of a path validator, I think what I did was I just added a new endpoint, /movies/movie ID /test. Now in here, there's meant to be a movie ID. So if I just go 34567, which happened to be the one that I just added, and I send that request, what I'm getting back is essentially the details of that particular movie. So that worked fine. So in this case, there is a path validator checking to see that there is a movie ID here. If I take it out, send my request, then this message is coming from API Gateway because it cannot find the movie ID path parameter in the request. And equally, the Lambda that's handling that request, it no longer has to check, well, is there a movie ID included? If there isn't, return an error response. It no longer needs that code. Could still be the case, though, that I give it an invalid movie ID, so it needs to deal with that case. Okay. Right. So clearly you need to do a little bit of Googling around API gateway request validators. And I guess you would need to include the CDK in that Google request, because it's really CDK code that you want to get. And that's really what I did. I did some Googling before I could come up with solutions. So see how you get on. Maybe you should try and do, I don't know, basic path validation first, then maybe body validation, then maybe query string validation. Or you could start with just body validation and then try and tackle the path parameter and query string parameter. Okay, I'm waffling a little bit. Let me see how we're on time. Is there anything else I wanted to? Again, I'll just pause just in case people have any questions as a result of all of that. Admittedly, now it's somewhat, I won't say incoherent, but Anyway, do you have any questions on that particular aspect or more generally about the assignment specification? No, okay. I'm thinking, was there something else I wanted to? Oh yeah, there was one other thing that I wanted to bring to your attention. And let's do the following. What I want to show you is the ability to create custom IAM policies within your CDK code. I've demonstrated using an earlier sample application that we looked at. So this is the CDK stack where we're just using lambdas and function URLs. Actually, we're not using any web API. So we have a table. How many tables do we have? We have, collapse that. We have our movies table, movie cast table. Uh, we have, okay, local secondary index, some seeding stuff, some lambdas, associated URLs, and we have these lines of code here. So if we take this line of code, what that allows, and before I do that, I need to do a CDK deploy while I'm talking. This line of code, single line of code, allows the particular lambda, the get movies by ID lambda, to have, it looks like, have read access to the movies table. And what I want to see is, well, what was the effect of that line of code? What was the effect of that line of code from the kind of cloud formation, and what did it actually generate um, for this application? So I need to let this run through before I can do that. So clearly it's going to create a Lambda resource, and it's going to create a DynamoDB resource, etc., etc. So if I now look at the Lambda, and it's the get movies by ID Lambda that I'm interested in, which is this one. And if we select the configuration tab and the permissions tab, I've talked about this G before. So behind the scenes, the CDK in conjunction with CloudFormation generated dynamically a role, an IAM role specifically for this Lambda. If I select that, I'm now in the IAM console. And what we can see here are there are two IAM policies attached to the IAM role, which is linked with the Lambda. This policy here was dynamically generated as a result of this single line of code. And if we look at the detail of the policy, then surprise, surprise, it's all about giving the Lambda access to particular parts of the DynamoDB Web API interface. As you know, every service has a Web API interface with various endpoints, and this looks like it's the DynamoDB interface, which would make sense. And in fact, it's almost over provisioning the Lambda's requirements. The Lambda only needs to, if we looked at the actual Lambda code itself, it only executes get requests, get item requests, or get items from the DynamoDB table. So some of the other permissions that have been granted here aren't really necessary. So could we write a custom IAM policy that is more restrictive than this policy that was dynamically generated? Could we do that from our CDK code? And the answer is yes. If I go back to my CDK, and if I just enable these few lines of code here, which, as they say, I prepared earlier. And what am I doing here? I am adding a policy to the role of this Lambda. And I'm specifying the policy here. I'm creating a new policy statement. This kind of language should be familiar to people that did the cloud architecture module in the first semester. But it looks like specifically what I want this policy to enable is, see, I've commented out a lot of stuff here, but I just want the policy to allow my Lambda to do this, right? To do a get item request against the DynamoDB service. The other ones that I've commented out here actually were taken directly from, I essentially cut and paste this, just to make life easier for myself. But I've commented them out. So the only one that's enabled is this one. So I've now added this specific policy to the role associated with this Lambda, which means I can now take out this line because that over provisioned. If I now do a CDK deploy again, and hopefully I should see that reflected in the policy that will be dynamically generated yet again for the Lambda. I'll just let that work its way through. Okay, that's completed. And let's drill down again. Go to configuration, permissions, and probably need to do a refresh. Here's the role. Here's the hopefully updated policy. Yep, and you can see the policy now is much more restrictive and is reflected exactly on what I is it reflecting it? Where does it say get item? Oh, oh yeah, get item is the only action that's being allowed. So the purpose of that was to show you that you can, at the CDK level, you can write your own, implement your own IAM policies. And in our case, we wanted to attach the policy to a Lambda. You will see something like that being used to allow your Lambda talk to the Amazon Translate service in that video that you need to watch. So I'm just showing it to you here as well. You can do it for any type of service, really, not just Amazon Translate. Okay, that took a lot longer than I expected, but there you go. So don't think there's any other part of the assignment specification that I need to go over with you. Again, I'll pause again in case there are any issues. No? Right, I will attend this week's lab, but Frank obviously will be attending the other labs from here on in. So that's fine. Talk to you on Thursday. Thanks. Bye-bye.